law of sines. When I talked about trigonometry, I said that trig worked with all triangles, but we just focused on how it affected right triangles, because right triangle trig is really where we use it a ton. However, for this 6.7, we're going to talk about triangles that are not right triangles. You cannot use trig the same way we did if it's not a right triangle. So we can no longer use opposite over adjacent and hypotenuse, because if you don't have a right triangle, you don't have a hypotenuse. Without having a hypotenuse, there's no real opposite and adjacents, because then you have two adjacents and it just doesn't work. Trig does not work the same. However, without going into huge details, what they realized is you can actually set up a proportion that you can then solve using trigonometry without even knowing opposites, adjacents, SOHCAHTOA, or any of that. So we have practiced using trig ratios to find the side lengths and angle measurements in a right triangle. The law of sines shows the proportional relationship between angles and their opposite sides. It can be used to find side lengths and angle measurements for any triangle given the right information. We'll talk about the right information down here in a second. But given that I have any triangle, I can set a proportion where we can say sine of angle A. Now remember, when I say sine, it's always an angle that goes in after it. So it's sine of angle A over side A, or that side that's directly across from it. So if you look at A corresponds to that side that's directly across from it. So you can still remember across. All right, sine of A over A is going to equal sine of B over side B, which would equal sine of C over side C. If you can plug in information into this, now we don't usually set it up as all three of them. We usually just set up as two, and you'll see that as an example. But if you can start filling in some of this information, we can use, remember we did that cross multiplication thing? We can go back and use that cross multiplication to actually solve for missing sides and missing angles. However, in order for this to work, we need to be able to put information in here. If we don't have enough information, we can't solve problems like this. Kind of like, let's think back to if I had a right triangle. If I had a quick right triangle and I told you that this was 30 degrees, and let's make it a trig problem, 22 degrees. Is that enough information to find a missing side using trig?
Yes.
Is it?
Wait, no.
What would you use, sine, cosine, or tangent?
You can't.
We don't have any other information. So we have to have the correct information to use trigonometry. So in order to use this, you must know all the information of at least one of these. So if I knew like angle A and side A, angle B and side B, but you need to know that entire thing. In order to have that, you must know an angle and the side across from it. Which leads us to what information allows me to use the law of sines. So the first way I know for a fact I can use the law of sines is if the triangle gives me the specific information of angle, included side, angle. This was called angle, side, angle. So if I give you a triangle with angle, side, angle information, you can now use the law of sines. Well, we can also do it if we are given two angles and the non-included side. What is that called if I want to use three letters, if it's two angles and the non-included side? Key, do you remember? Side, angle, angle, or angle, angle, side. I usually do angle, angle, side, but there's absolutely nothing wrong with side, angle, angle. So if I'm given a triangle with angle, side, angle information or angle, angle, side information, I can immediately use the law of sines. Now, for me personally, I don't like going that route. It's awesome. Got those 3 bits of information. It works. here's my advice to you. If you know a side and the angle across from it, you are using the law of sines. If you know a side and the angle across from it, you can use the law of sines. And I'm actually going to put that in right here. I'm going to say, when you know a side and the angle across. When you know a side.
Is that for every single one?
Yep. And the
So how
angle.
would that first one be?
We're going to cover that in a second. That's a great question. When you know a side and the angle across, we can use the law of sines. In fact, this is going to be the big check I'm going to do. What I'm going to do is I'm going to circle something. I'm going to say, okay, do I know a side and the angle across from it? So in order to determine that, I'm going to circle a side length and the angle opposite it. And my job is, do we know both bits of information? Now, the question came up, what if I don't know that? Can we find it from the information that was given to us? Yes. So although there's nothing here right now, what would it be? Yeah.
You just do 55 plus 32 plus x equals 180.
Yep. I'm going to shortcut that just because we've done this for a while. So I'm just going to do kind of 180 minus 55 minus 32. What is the degree measure there? Say that again? 93. Can I get a second on 93 degrees?
Yes.
Okay, so that's why both of these rely on you knowing two angles, because if you know two angles, you know the third angle. So no matter if we're doing this today or we're doing law of cosines or we're doing ones where we're not sure, if I ever give you two angles, just immediately find the third angle. Automatically. No matter what I ask, if I give you two angles, you find the third angle. So right here, we're going to notice I have a side and the angle across from it. But we also know that, well, that would be that 93 degrees again. I would just go ahead and find that right off the bat. So anytime I give you two angles, I gave you three angles. Anytime we have three angles in a side, I can always circle a side and the angle across from it. So my shortcut for these, so today we're just doing law of sines, so they're all going to fit this situation. But tomorrow we're going to do law of cosines. And then we're going to have a day where we're not sure which ones to use. My advice is just, if I want to use the law of sines, make sure you know a side and the angle across from it. If you do, you use law of sines. All right, let's say we can use law of sines. So let's go on to some problems. So I have 1 and 2. Now I said the very first thing you should do is you should find that third angle. First step is always find that third angle. What is that third angle? Mason?
74.
74. Did anyone else get 74 degrees? We're good with 74 degrees? All right. So we have 74 degrees there. Now, to use law of sines, I must have an angle and the side across from it. I'm going to circle both bits of these information. Both of those talk about sides and both of those talk about an angle. Is one of those fully filled out? Does one of those, do I know an angle and the side across from it?
Yes.
Okay, yeah. So this one right here tells me use law of sines. We might also say that they gave me angle, angle, side, which works as well. So two angles aside, and we can do that. All right, so we can use the law of sines. And let's talk about why I can use the law of sines. The law of sines says, well, if I take sine of an angle, I'm going to use the 93 degrees over the side opposite, 12. I'm actually going to slide that down just a little bit. What was that? I got it. Oh, I don't know. It should have been 35. I can't even say where I came from. Just one of those brain things. Sine of 35 equals that side, or goes over that side across from it. So 35 is across from 12. And what we're going to do is we're going to set that equal to any other angle that we know information about and the side across from it. So I'm going to go with the sine of 71 degrees is across from side x. So once again, this is our key. The key is I can fill out one of these. Sine of an angle over the side across from it equals sine of 71 and the side across from it. I just don't know that one. Yeah.
What will you round to?
We're going to round to the 10th. Yeah. But to solve this one, I'm going to use that cross multiplication. As long as you have a fraction on either side, you can multiply across like that, which would then give me x times sine of 35 degrees equals 12 times sine of 71 degrees. I want x by itself. How do I move this sine of 35 to the other side? I want to move the entire quantity. I'm not trying to get rid of it. I'm trying to move it. Divide. Because what is it attached by? It's attached by multiplication. The inverse of multiplication is division. So to move it to the other side, you are going to divide both sides by 35. I'm going to go ahead and throw it like this. Divide by sine of 35 degrees. Divide both sides by sine of 35 degrees. And that's now going to give me x equals 12 times the sine of 71 degrees divided by sine of 35 degrees. This is going to be something we throw in our calculator, obviously, because I don't think we're able to do that in our head. Griffin, what did you come up with? 19.8. I'm going to give it a second. I would like everyone to plug in your calculator and make sure you can plug this in. If you can't plug this in, you can't get these problems correct. You got 19.8. It's not mental math. This is not mental math. This is plug it in your calculator math. 19.8. 19.8. Did we all get 19.8? Are we going with 19.8? Okay, then I'm going to move on. We have 19.8 rounded to the nearest tenth. Is this obnoxiously hard? No, it shouldn't be. It's just we're going to throw more stuff at you when we get to law of cosines. That's where we start confusing things. So first of all, we need to memorize the formula, and we need to know when we can use it. So we can use it anytime we know a side and the angle across from it. Michael?
So 19.8 would be the side?
19.8 would be the side length, correct. Yes?
So we just use sine for all the stuff we're working on today?
Yes.
Will we ever have to be like trying to find the degree?
I don't know. Let's just hold off on that. Okay. All right. So our next one, number two. Number two. This is how I decide I can use the law of sines. Well, first of all, I should find the missing angle. Because I'm going to tell you right now on our third day, it's just solving the triangle. You have to tell me every bit of information you can gather from it. Today, I'm specifically asking stuff. So let's get in the habit of doing this. What is that missing angle?
48.
48 degrees. Are we good with 48? I heard it from a couple people. Okay, so we have 48 degrees. I don't need it because what I need is I need an angle. Do you see that 18 degrees? What's across from that 18 degrees? That 5. So I have, I'm going to avoid that. So I have that key. I have that key that tells me I can use the law of sines. I promise you want to start doing that check. Because when we start learning the law of cosines, we're going to have different rules. So let's keep it simple right now. Let's do that check. Make sure you have an angle and the side across from it. That means you can use the law of sines. So that is our key. So we're going to go ahead and go, okay, that means the sine of that angle, 18 degrees, is across from 5. So I can do sine of 18 over 5. Is going to equal, what am I going to put on the other side? Who has figured it out after our one problem? What am I going to put on the other side of that equal sign key? Sine?
Sine, so 1/4 over x.
1/4 over x. Perfect. So our angle always goes across from that side that's across from it, or on top of it. Now to simplify this, we'll just use our cross multiplication. Our cross multiplication looks like this, that x goes to that sine of 18, that 5 goes to that sine of 114. So we're going to have x times sine of 18 degrees equals 5 times the sine of 114 degrees. Take a second. How do I move that sine over to the other side? Don't yell it out. Raise your hand. How do I move that sine of 18 to the other side? What operation am I using? Tito? We're going to use division. So that's going to turn into x equals 5 times the sine of 114 all over sine of 18 degrees. Take a second. Don't shout out the answer. I'm looking for what is 5 times sine of 124 divided by sine of 18. Don't shout it out. I'd like everyone to be able to put it in their calculator.
Isn't it 114?
Yeah, 114. Isn't it 114?
Yeah.
Oh, okay. Oh, no, 114. Maybe that looks like a little bit of a 2. All right, so we're looking for 5 times sine of 114, sine of 18 degrees. You got it? 14.8. 14.8. Can I get a second on 14.8? All right, a lot of hands went up. So we have 14.8. That is our side length. So that is how we find our side length. I'm going to skip the next one for a second. I want to go on to how do we find an angle. Angle is going to be the more difficult of the versions. Now, can someone explain to me how do I know to use the law of sines on number 4? Yeah.
There's an angle and a side that are lined up.
There's an angle and a side that are lined up. So I'm looking at that 77 degrees and that 14. That is our key that tells me use law of sines. All right, so now we're going to have sine of 77 over 14. Can someone raise your hand and tell me what I write on the other side? Someone besides Key, because he got that. Yeah, Griffin. Sine of x over 9. Now, I want to notice a difference. Look at where the x is. That x is trapped inside that sine. Does anyone remember? We're not doing it yet. I'm just forward thinking. How do I get rid of sine? I need to do that sine inverse, which is that sine to the -1. So at some point, I must have to take the sine inverse. But let's hold on to that. Let's just do our cross multiplication and see where we're at. So let's do our cross multiplication. That's going to give me 14 times the sine of x equals 9 times the sine of 77 degrees. So I am going to note I can't just use division. I can't just use division to get sine over there, but I can use division to get the 14 over there. I want to get as much stuff out of the way as I can before I deal with that sine. So your first step should be divide both sides by that 14. You got to get it out of the way. You got to isolate. So we're going to divide both sides by 14. Divide this side by 14. And suddenly we have sine of x equals 9 times sine of 77 degrees all over 14. Now, we're going to do something here. I don't want to plug too much stuff in my calculator because a lot of us don't have those graphing calculators, so we kind of mess up stuff. What I'm going to do right now is I'm actually going to plug just this one in my calculator. I'm going to plug in 9 times sine of 77 over 14, and I want 4 decimal places because I am kind of cheating it. So I need to get as many decimals as I can. So here we're going to do 4 decimals. So I'm going to type in 9 times sine of 77 degrees divided by 14. And I'm going to give you what I got out, just so you can see how I'm doing this. So I'm going to get out 0.6264. That is 4 decimal places. So we're doing 4 decimal places because if I round it to the 10th, we're cutting off a ton of information because it's such a small number. All right, so currently I have sine of x equals 0.6264. Now we're going to do what Jack said. Take the sine inverse of both sides. So we're going to take the sine inverse of both sides. This will look something like this. Take the sine inverse of this side. I'm going to kind of cram it in here. Take the sine inverse of this side. My sine inverse and sine cancel out, leave me with just x. It's like squaring a square root. You are undoing it. So taking that sine inverse cancels out that sine, and that's going to give me x equals the sine inverse of 0.6264. Can someone plug that in your calculator and give me it to the nearest tenth? Possibly someone that hasn't given me an answer yet. Jake? 38.8. Did anyone else get a 38.8? Yeah. Cool. Who in here has a graphing calculator? If you have a graphing calculator, it is possible to do sine inverse of all of this stuff. So you could just type in sine inverse of 9 times sine times of 77 divided by 14. You could plug it all in at once. Your calculators can do it as well, some of the more advanced ones. Yeah?
So all the calculators are just like parentheses, multiply, right? So you don't have to change anything like that?
Right. Yep. So if you have a good enough calculator, you can actually take all of this information and just plug it in there if you don't want to do it bit by bit. You'll get a slightly more exact answer, but generally it's going to be the same answer as everyone else. It's just, how do you feel comfortable-wise on your calculator? Are you more comfortable plugging everything in, or are you more comfortable just taking a break, getting your 4 decimals, and then continuing on?
How do you know, like, if it doesn't come out the exact same?
It will come out pretty much the exact same, 99.9% of the time. Sometimes it might be just a decimal point off, but I mean, I will know what you did based upon the work that you write out. If I see you wrote this in, I know you're plugging this in. If I don't see you write this decimal, I know you did the whole thing. Okay, do we all hear that? I know some of us are talking to each other for some reason. Did we all hear that about our calculator? It's important to know that individually, we all have different skill sets. Some people like plugging things in calculators. Other people like taking that break and then plugging in the decimal. All right, my next one. Can someone tell me, how do I know to use the law of sines? Except for Mason, because he told me last one. How do I know to use the law of sines here? Yes, Lynn?
Do we have 2 sides already across from each other that are numbered, I guess?
Yeah. I'm looking for just one particular one. I'm looking for this one right here. But yes, you are correct, because there's another pair that I have to pair it up with. So we have that 126 over 31. I will also note that in these problems, I don't have 2 angles, so I'm just looking for the one they're telling me to. So we can do sine of 126 divided by 31, and that's going to equal what? Can someone that hasn't given me the other side? What do I put on this side? You already gave me one. Gianluca?
Would it be sine x
Mm-hmm.
over 15?
It would be perfect. Then we just do our cross multiplication, where I do that 31 times that sine of x. I do that 15 times that. So we're going to turn this into 31 times sine of x equals 31. I'm sorry, I just did that. Equals 15 times sine of 126 degrees. We do have to move the 31 to the other side first before you do anything else. So we have to do division to get 31 to the other side. That's going to give me sine of x equals 15 sine of 126 degrees divided by 31. Now, here's the benefit of someone that just wants to plug stuff in the calculator. You know everything you need to plug in the calculator right now. We could just type in sine inverse of 15 times sine of 126 divided by 31, or we can round it to 4 decimal places. I'm going to go ahead and I'm going to, for our calculator enthusiasts, I'm going to move the sine over here by taking the sine inverse of both sides. And maybe even if you're not 100% proficient at using calculators, here's a nice little shortcut. Why write this all again when I know I'm doing the sine inverse of it? I'll just put a little arrow and say I'm putting this in my calculator. Let's all try putting sine inverse of 15 times sine of 126 divided by 31 and see if we can all get our answers by just plugging that whole thing in. Did anyone get this one? Yeah.
I just have another question.
Oh, yeah.
I like to plug in the whole thing in the calculator, but like when you're doing like the algebra, you know, it's like write it out like with 3 more steps. Can I just put like ands in place of that?
And?
Like you know, like calculator stuff, like answer.
Oh, yeah.
Could I just write that down?
That you're putting answer in? Yeah. That's what I'm basically doing here. See, I'm putting a little arrow down here. Like I would just put a little arrow and say I used that in there. Can someone tell me what x equals? Michael? 23.0. Are we okay with 23.0? There is one small thing I missed on the other one. Does anyone know what I missed on this answer, this 38.8? Degrees. I do have the x equals because I started off with that. That's fine. But I did forget to put the degrees. It's not a big deal. I'm not going to take points off from it, but we should realize that it is an angle measure. Now, I'm just prepping us for a future lesson. If I know this one and this one, is it hard to get the third angle?
Nope.
Are you going to use the law of sines to get the third angle? No, we're just going to use subtraction. All right. If you've been playing along, you know I skipped 2 problems. I skipped number 3, and I have not done number 6. You are doing number 3 and number 6. You could do it as partners. You could do it in your group. You could do it individually. But I do need to check it off that you can do it. So right now I need both of those done as soon as you